Hey everyone, and welcome. So, if you've ever stared at your JavaScript code, just pulling your hair out, wondering why on earth things are not running in the order you wrote them, well, you are in exactly the right place. Today, we're going to tackle one of the most important and sometimes confusing concepts in programming: synchronous versus asynchronous code.
Let's start with a really simple analogy that I love, the coffee shop. So picture this. Synchronous code is like that one long, slow-moving line. You place your order, and then you and everyone behind you just stand there, completely blocked, waiting for that one latte to be made. Nothing else happens. But asynchronous code, that's the game changer. You place your order, they hand you one of those little vibrating buzzers, and you're free. You can go find a table, check your phone, whatever. The work is happening in the background, and you just get notified when it's done. That's the non-blocking power we're going to dive into.
So, what does this actually look like when we're writing code? And more importantly, why is understanding this so critical? Okay, let's put these two head to head. On one side, you've got code that's like a soldier, marching one step at a time. And on the other, you've got this amazing multitasking power that makes modern apps feel so fast and smooth. Here it is, the key distinction. Synchronous code is blocking, and I want you to remember that word. Just like that coffee line, the entire program literally halts and waits for a task to finish before it can move on to the next line. Asynchronous code, on the other hand, is non-blocking. It kicks off a bigger task, like, say, fetching data from a server, and then, and this is the magic part, it immediately moves on to the next line of code. It doesn't wait around, it lets that other stuff happen in the background. All right, enough theory, right? Let's get our hands dirty. The best way to understand this is to see it work with a classic JavaScript example. This is where it's really going to click for you. Okay, take a look at this. We've got three simple lines. The first line, console.log first, that's easy, it just prints first. Same with the last line, it's going to print third. But this guy in the middle, setTimeout, he's the special one. This is an asynchronous function. We're telling it, hey, I want you to run this little piece of code, the part that logs second, but don't do it right away. Wait 2,000 milliseconds or 2 seconds before you do it. So here's the pop quiz. If you were just reading this top to bottom, you'd expect to see first, then a 2-second pause, then second, then third, right? But we just learned that setTimeout is asynchronous. So take a second, think about it. What do you think the actual output order is going to be? Lock in your answer. And if you guessed first, then third, and then finally second, you nailed it. So here's why. The JavaScript engine runs the first line and prints first. Then it sees timeout. It says, okay, got it. I need to run this second thing in 2 seconds. It sets a timer in the background, and this is key. It immediately moves on. It doesn't wait. So it goes right to the next line and prints third. Then 2 seconds later, that timer goes off, and second finally appears in the console. The program never froze. It kept on working. That is the magic of asynchronous code. So, okay, this isn't just some neat little coding trivia. Understanding this concept is absolutely mission critical, both for building great apps and for acing that next technical interview. I mean, just think about it. When your app needs to get data from an API over the internet, you can't have the entire screen just freeze and become unresponsive while it's waiting, right? That's a horrible user experience. Async code lets the app stay snappy and usable. The same thing goes for handling button clicks or running heavy calculations. And because this is so fundamental to building performant apps, you can bet that interviewers love to ask about it. They want to know if you really get how to write efficient, non-blocking code. All right, so we've unpacked the what and the why of sync versus async. Now I want to turn this over to you. If this explainer really helped things click into place for you, do me a huge favor and hit that like button and subscribe for more deep dives like this. And I really want to hear from you in the comments. Have you ever been totally stumped by an async bug in your own code? We've all been there. But before you go, here's something to think about. We looked at setTimeout, but in modern JavaScript, we have even better tools like promises and async await. So the real question is, how do those tools build on this core non-blocking idea to save us from what's called callback hell? Let that one sink in. Thanks so much for watching.